Have you ever wondered how our universe came into existence? It's a question that has boggled the minds of philosophers, scientists, and thinkers throughout history. The most widely accepted explanation is the Big Bang Theory. This isn't a theory in the everyday sense of the word, but rather a comprehensive explanation that has stood up to rigorous testing and scrutiny. About 13.8 billion years ago, give or take a few million years, our universe wasn't a universe at all. It was a singularity, a point of infinite density and temperature. Then, in a fraction of a second, this singularity expanded in what we now call the Big Bang. This wasn't an explosion in the traditional sense, but rather a rapid expansion of space itself. This momentous event led to the creation of everything we know today, from the tiniest particles to the vast galaxies stretching out into the infinite cosmos. So the Big Bang wasn't just an event, it was the beginning of everything. But what happened in the first few moments after the Big Bang? In the immediate aftermath of the Big Bang, the universe was a hot, dense sea of energy, a state often referred to as the primordial soup. As the universe began to cool down, this energy started to transform into subatomic particles. We're talking about quarks, electrons, and neutrinos here. These subatomic particles didn't just sit idle. They began to combine, forming the first atoms. Imagine that, the very building blocks of matter being created from pure energy. The universe at this stage was a lot different from what we know today. It was incredibly hot, so much so that matter as we know it couldn't exist. As time went on, the universe expanded, cooling down in the process. This expansion and cooling allowed atoms to form and eventually clump together to form stars and galaxies. In a nutshell, the first few moments were all about formation and transformation. So, when did the galaxies, stars, and planets we see today start to form? The answer takes us back in time, about 1 billion years after the Big Bang. The universe was a much different place then, filled with a dense soup of matter and energy. As the universe expanded and cooled, gravity began to pull this matter together. Now, envision the universe as a cosmic web, with strands of matter stretching across the vastness of space, creating pockets of dense areas. In these dense areas, galaxies began to form like cosmic metropolises, each housing billions and billions of stars. The formation of galaxies wasn't a quick process, mind you. It took hundreds of millions of years for gravity to sculpt the raw matter into spinning disks and elliptical shapes we associate with galaxies today. Within these galaxies, stars began to form. Deep inside the dense, gas-rich regions, gravity compressed the gas and dust, igniting nuclear fusion and giving birth to stars. Around these stars, planets formed from the remaining dust and gas, creating a stage for the potential existence of life. The universe we see today is filled with galaxies, each a testament to the power of gravity and the passage of time. From the primordial soup of the early universe to the vast cosmic structures we see today, it's a story of evolution on a cosmic scale. Indeed, the formation of galaxies was a significant step in the universe's evolution. Now that we've traveled billions of years back in time, what about the present state of our universe? Brace yourselves as we delve into the here and now of our cosmic home. Our universe, in its current state, continues to expand. This isn't a slow, leisurely stretch. Oh no, it's a rapid, relentless expansion. Imagine a balloon being inflated, each galaxy drifting further apart from its neighbors. But what's causing this cosmic stretch, you might wonder? Enter dark energy and dark matter, the elusive forces that make up a staggering 95% of the universe. They're like the invisible puppet masters, pulling the strings of cosmic expansion yet remaining hidden from our sight. As for the future, well, it's a cosmic mystery. Will the universe continue to expand indefinitely, or will it eventually collapse? Only time will tell. In essence, our universe is still evolving, and there's much more to explore. So buckle up, space travelers. Our journey through the cosmos is far from over. To sum up, the universe has come a long way since its birth in the Big Bang. Born from an explosion of unimaginable energy, it rapidly expanded, cooling and coalescing into the first atoms. These atoms clustered to form stars, and stars grouped to create galaxies. Today, our universe is a vast, ever-expanding frontier of countless galaxies. And as we continue to explore, who knows what fascinating discoveries await us in the depths of the cosmos.